Hello everyone. This video will explain how to realize the basic logic gates using universal gates. First, let us see how to implement or how we can realize the basic logic gates using NAND gate. The first is a NOT gate, which is nothing but an inverter. Here the input being A and its output will be A bar usually. And this can be designed using a NAND gate like a NAND gate with the same input A has to be given twice to the NAND gate and its output will be A bar here because A dot A whole bar will be A bar. And the next is an AND gate with A and B as inputs, and this can be realized using an AND gate in this way, like the inputs A and B has to be given to an AND gate and its output has to be again given to another NAND gate, and hence the final output will be A dot B. And in case of OR gate with inputs A and B, it can be realized using a NAND gate like for the input A NAND gate has to be used, and for B also a separate NAND gate with the same input given twice, and the outputs of A, the NAND gate which is fed with A and B, has to be given to another NAND gate and its output will give an final output as A plus B. Right? This is how we realize the basic logic gates using NAND gate. Next, let us see the procedure to implement the Boolean function using NAND gates. Realize the given Boolean function using AND OR logic first. And the second step is, if NAND logic has to be implemented, add bubbles at the output of AND gate and then add bubbles at the input of OR gate. The third step is replace NOT gate by NAND gate and give the same input twice. Next, the bubbled OR is a NAND gate, hence replace that by using a NAND gate. The final step is, if there is any single input, give the same input twice to the NAND gate. Let us see expression. Implement the following Boolean function using a NAND gate. The expression is f equal to AB plus AB bar plus A bar B. The first step is to realize this expression using AND OR logic. So for implementing this Boolean expression using AND OR logic, we need three AND gates. The first AND gate has to be given with A and B, and for the next AND gate, A and B bar has to be given. B bar is nothing but giving the B input to an inverter, and the output of the inverter has to be given to the AND gate. And for the third AND gate, we need to give A bar and B. Right? Now the outputs of this AND gates has to be given as input to the OR gates like this. So the output of this OR gate will be the final output F. So this is what or how we realize the given Boolean function using AND OR logic. Step 2 is add bubbles at the output of AND gate. So here we have three AND gates. We have to add bubbles at its output. For each of the AND gate we need to add a bubble. So this is how we add add bubbles at the outputs. The step 3 is add bubbles at the input of OR gate. Here we have only one OR gate, and in that OR gate we have three inputs. We need to add bubbles to these three inputs. So this is step 3. So next, step 4 is replace NOT gate by NAND gate and give the same input twice. So here we have two NOT gates and this has to be replaced by a NAND gate, and the same input has to be given twice to that gate. So this is how we replace NOT gate by NAND gate, and we gave the same input twice. And next, step 5 is bubbled OR is a NAND gate. Here this is bubbled OR and this can be replaced by a NAND gate, and we can replace by this way. And if you see this AND gate which has an output, bubble at the output is nothing but a NAND gate. So we can just put it this way, since this is a NAND gate. So this is how we realize a Boolean function using NAND logic. Next, Let's see how the basic logic gates can be realized using a NOR gate. First, the inverter with A as input and its output has to be A bar. So it can be realized using a NOR gate by giving the same input twice. So it will give the output as A bar. Next is an OR gate. So for OR gate, first the variables A and B can be fed to one NOR gate and its output can again be given to another NOR gate with the same input twice. So this will give an output as A plus B. Next is an AND gate. So for AND gate, we need 3 NOR gates. For the variable A, we need an AND gate with the same input given twice, and for B also the same, and the output of both these NOR gates has to be given to the next NOR gate. So this final output will be A dot B. So this is how we realize the basic logic gates using NOR gate. Next, let us implement a Boolean function using NOR gate. Let's see the procedure first. Realize the given Boolean function using AND OR logic. If NOR logic has to be implemented, first add bubbles at the output of OR gate and then add bubbles at the input of AND gate. Then replace NOT gate by NOR gate and give the same input twice. The next step is bubbled AND is NOR gate, hence replace it by NOR gate. The final step is if single input is there, give the same input twice to the NOR gate. This is how we design or we implement a Boolean function using NOR gates. Let's see a problem. Let's have the same problem with f equal to AB plus AB bar plus A bar B. This has to be realized using a NOR gate. So the first step is realize the given function using AND OR logic. As we have seen this, like we have 3 AND gates. The first AND gate has to be implemented like this with the A and B as inputs, and the second one with A and B bar as inputs, and the third one with A bar and B as inputs. So these outputs of AND gates has to be fed as input for the OR gates, and the final output will be F. Now step 2, add bubbles at the output of OR gate. Here we have only one OR gate, and to that output we have to add a bubble. And the step 3 is add bubbles at the input of AND gate. Here we have 3 AND gates, and for each of the 3 AND gates we have 2 inputs. For this we need to add bubbles at all the inputs of the AND gate. So this is how we add bubbles at the input of AND gate. And the next step is replace NOT gate by NOR gate and give the same input twice. Here we have 2 NOT gates and it has to be replaced with the NOR gate, and we have to give the same input twice, and this is how it will be. And step 5 is bubbled AND is NOR gate, hence replace it by a NOR gate. So we have 3 bubbled AND here. So this has to be replaced by NOR gate. We can do it this way. And now this, if you see, this is nothing but a NOR gate. So just we can have it as it is. So this is how we realize a Boolean function using NOR gate. Thank you.